Can code predict who will default on a loan before the bank approves it? In this project, I analyzed 2015 loan applications, where 20.4% ended in default. I cleaned the data, performed EDA, engineered features, and trained a logistic regression model using Python, pandas, numpy, matplotlib, and sklearn to identify high-risk applicants before approval. This is how machine learning powers smarter lending decisions. Follow DataPeak Solutions for more real-world data analytics and AI projects. Every great machine learning model starts with one thing: understanding the data. In this step, I loaded the loan dataset using pandas and explored its structure. The dataset contains 2015 loan applications with 12 features. I checked the shape, previewed the records, verified data types, and scanned for missing values. That quickly revealed gaps in columns like annual income and employment years, highlighting the data quality issues that must be fixed before building a reliable credit risk model. Next, we'll clean and prepare this data for machine learning. Garbage in, garbage out. Your AI model is only as good as the data you feed it. This is where every successful machine learning project begins: data cleaning. First, I removed duplicate records, reducing the dataset from 2015 to 2,000 rows. Then I handled missing values using median imputation, making the data more robust against outliers. Finally, I converted categorical columns into optimized data types, improving memory efficiency and processing speed. Remember, models don't fail because of algorithms. They fail because of messy data. Professional data scientists rely on numpy vectorization because it's faster, cleaner, and built for large data sets. Instead of looping through thousands of rows, I transformed entire columns in a single operation. First, I created a debt-to-income ratio to measure repayment risk. Next, I applied a log transformation to reduce income skew and improve model performance. Finally, I calculated credit utilization, a strong indicator of borrower exposure. These engineered features give machine learning models richer patterns to learn from, without sacrificing speed. That's how you build production-ready ML pipelines. Never trust your data until you've visualized it. One chart can expose what thousands of rows hide. This is exploratory data analysis, where raw numbers start telling a story. The credit score distribution clusters around 650, giving us a snapshot of the average applicant. The debt-to-income ratio is heavily right-skewed, meaning a small group carries much higher financial risk. Most applicants stay below a 1.0 ratio, indicating manageable debt levels. These insights reveal patterns, detect outliers, and guide smarter feature engineering before building any machine learning model. A correlation heat map can reveal in 10 seconds what thousands of rows never will. This is where exploratory data analysis uncovers the relationships hidden inside the data. Using a correlation heat map, I measured how every feature connects with loan default. Credit score shows the strongest negative relationship. Higher scores usually mean lower default risk. Debt to income and credit utilization move together, highlighting borrowers with higher financial exposure. Meanwhile, annual income alone has only a weak correlation with default. These insights help eliminate redundant features, identify the most predictive variables, and build smarter machine learning models. Your model doesn't understand words. It only understands numbers. That's why feature engineering changes everything. Raw data isn't ready for machine learning. First, I grouped annual income into meaningful brackets like low, medium, high, and very high using PD dot. Cut open parenthesis, close parenthesis. Then I applied one-hot encoding to convert categorical features such as loan purpose, home ownership, and income brackets into numerical columns. This transforms messy business data into a format that machine learning algorithms can actually learn from, improving both accuracy and model performance. A great model can still fail if you split your data the wrong way. Before training any machine learning model, the dataset must be split correctly. I used an 80-to-20 train test split with stratification to keep the default rate balanced in both datasets. Then I applied standard scalar, fitting it only on the training data to prevent data leakage and ensure fair evaluation. Scaling is essential for algorithms like logistic regression, while random forest doesn't require it because tree-based models are scale-independent. A proper split and scaling strategy ensures your model learns correctly and performs reliably on unseen data. Can one simple algorithm predict loan defaults with over 92% accuracy? Let's find out. This is my baseline logistic regression model for credit risk prediction. After cleaning the data, engineering features, and scaling the inputs, I trained the model to classify whether a borrower is likely to default. The result? An impressive ROC-AUC score of 0.926, showing excellent ability to separate risky and safe applicants. Logistic regression is fast, highly interpretable, and often the first model data scientists build before trying more complex algorithms. Moving ahead. Here, instead of relying on one tree, Random Forest builds hundreds of decision trees and combines their predictions. Each tree learns from a different sample of the data, reducing overfitting and improving accuracy. Here, we trained a random forest with 300 trees, balanced class weights to handle the loan default imbalance, and predicted the probability of default for every customer. The result? A strong ROC-AUC score of 0.897, meaning the model separates risky and safe borrowers with high confidence. After training the model, it's time to measure its real performance. The confusion matrix shows exactly where predictions are correct and where mistakes happen. In this case, 279 safe applicants were correctly identified, while 54 actual defaults were successfully detected. Then comes the ROC curve, which measures how well the model separates risky borrowers from safe ones. With an AUC of 0.897, the model demonstrates strong predictive power. Because in machine learning, evaluation isn't about one metric. It's about understanding every prediction. After training the random forest model, I analyzed which features had the biggest impact on loan default prediction. The clear winner was credit score, making it the strongest predictor of borrower risk. Next came loan amount, age, and debt-to-income ratio, all contributing meaningful signals to the model. On the other hand, features like number of credit lines had very little influence. Feature importance doesn't just improve model interpretation, it helps simplify models, remove unnecessary variables, and focus on what truly drives predictions. After building and comparing multiple models, the results were surprising. Logistic regression achieved an AUC of 0.926, outperforming the more complex random forest, which scored 0.897. This tells us the relationship between the features and loan default is largely linear, making a simpler model the better choice. The biggest lesson? Never assume a complex algorithm is superior. Always benchmark against a strong baseline, compare performance objectively, and let the data decide which model wins. Here's the entire credit risk prediction pipeline in just 4 Python libraries. NumPy powers the mathematical computations and feature calculations. Pandas loads, cleans, transforms, and structures the dataset. Matplotlib turns raw numbers into visual insights through charts, distributions, and correlation analysis. And finally, scikit-learn trains, evaluates, and compares machine learning models to predict loan defaults. Master these 4 libraries, and you'll have the foundation to build real-world AI and data science projects from start to finish. Don't just watch the project, build it yourself. This is Project 3, an end-to-end credit risk prediction pipeline built completely in Python. The complete source code, dataset, and project files are available on GitHub, and the full walkthrough is now live on YouTube. Check the links in the description and follow DataPeak Solutions for more real-world AI, machine learning, and data analytics projects.